Hi, thanks for joining. We'll be talking today about SparkOscope and how it can help you have a better understanding on your Spark jobs, on the operating system, how the operating system works while you run your Spark jobs, how to visualize those data and get better insights when you are planning for your infrastructure needs. So I'm Yiannis. This is the mandatory who am I slide. I've been working in IBM Research in Dublin since 2012 as a research software engineer. It's a fairly new lab established in 2011. We're celebrating 5 years, 2016. So basically, my work is focused around analytics foundations middleware, whatever that means. So it's basically work around distributed frameworks, anything having to do with Hadoop, Spark, HBase. I love Java and Scala-based technologies. I like working on those. And of course, I'm getting excited with web-based proof of concepts. That's why these skills were needed also to develop SparkOscope, as you will see. Basically, I'm the UI guy for the high-performance systems group, led by Kostas. That's why he's first. Andrea, Khalid, Michael, Mustafa, and Pierre, and Sri. Okay, so I'm gonna explain how we get to start developing around Spark and trying to improve Spark and specifically the monitoring part of Spark. So we just enjoyed so much writing our analytical workloads on Spark. We tried Hadoop and MapReduce, of course, in the beginning, but the performance and the ease of development made it really obvious that we should switch quickly to Spark. We have fully embraced internally in IBM Research in Ireland since the very first versions of 1.0. Actually, before even the official announcements by IBM and so on. So the target use case that we had was mostly had to do with energy-related sensor data with a big customer in the US. So we have been developing our Spark jobs on this large volume of energy-related sensor data. So of course, as the type of this use case required that once we have developed the required jobs, right, they were executed then in a recurring fashion. That's it because the data were coming in every day. We were receiving a new batch of data every day, and we had to apply this. Once we have reached a level of maturity on these jobs, we had to apply the same transformation, the same filtering on a new set of data. So these jobs were executed on a daily basis. So therefore, we had to plan ahead we had to plan ahead for our infrastructure needs because the data, as you can imagine, they were accumulated and they were growing. So therefore, we're starting to reach some the limits of our hardware. So, of course, in the process of developing the Spark jobs, we're hitting different types of bugs, right? Of course, there was some bugs on our code, null pointer exception, something else, which we could very clearly and easily see and discover on the Spark default WebUI, right? Sometimes was also because the data weren't really strictly structured. There were, on one column, it was supposed to be a number and it was a string, and so on and so forth. So using the WebUI, the default Spark WebUI, it was very easy to track down to what exactly stage failed and which line number in our source code failed. As I said, we're starting to experience some slowdowns that had to do with our infrastructure, right? We didn't have infinite resources to run these jobs, right? The problem that we had was that by using the Spark WebUI, we couldn't easily identify at which part of the code, at which stage the bottleneck was caused because of our hardware, because of the limitation of our hardware. Also, we couldn't really trace back and see what was the parts of the code that were causing this bottleneck. What operation were we trying to run when this bottleneck was happening? Spark, of course, has its monitoring framework. One of the options that was available to us to get some better understanding on what's happening under the hood in the system level was, of course, the Ganglia extension. There was an option for us that we considered in the beginning, but we felt that there are some drawbacks to that. We had to maintain and configure yet another external system. And also, there was no association of the metrics exported with the actual job or stage or source code of the Spark job. And in the end, we really like the Spark WebUI, the default WebUI. We find it handy, and we wanted to consolidate all of our metrics there. So, as I mentioned, the default Spark monitoring framework supports an operation that exports all the metrics on CSVs. So these CSVs are exported. You can get metrics about the HDFS, reads, writes, about the number of tasks running, and they were all the default CSV sync writes those metrics into the local file system. And we found that it was a bit cumbersome to collect all those different CSV files, aggregate them, make the association, make the temporal association with the jobs that were running on our Spark cluster at that point. So the whole procedure seemed a bit cumbersome. Again, it was tough to get those associations with the source code of the job. Just as I explained before, this is a very rough outline of the current monitoring architecture, how it looks like on Spark. You have the separate workers on different nodes, and the different executors being launched on those machines. And by using the executor source, which you can also attach a different one, JVM source, which just generates a different type of metrics. It's written then to a CSV file on the local file system. Just to give you, so basically, if you look, I run a job and specified that I want to use the default CSV sync. It will look like this on your local file system, right? You will have all those different CSV files. And they will, inside that, there is the time series and the value, there is the timestamp and the value for each of those metrics, like the HDFS, write bytes, and of course the app is the application ID part. So that's why we started developing SparkOscope. And as my friends make fun of me, that I claim that every word comes from Greek. It's actually true for this. It's a combination of Spark and Skopin, which is the Greek for look at, so it's pronounced like stethoscope, but instead it's SparkOscope. Okay, so what is it exactly, right? So what we have built is an extension to enrich the Spark existing monitoring framework with operating system level metrics. For that, we used, so one module that we developed was the cigar source, which basically utilizes the Hyperic cigar library to get the operating system level metrics. And basically, this library is just, it offers a Java API and supports all the major operating systems. You can get the CPU utilization, the network bandwidth being used, the disk read-writes. And so we developed this cigar source to attach to every executor. And on top of that, we also developed the HDFS sync. So it's the same concept as the CSV sync, but with the difference that now it writes on the HDFS instead. And by utilizing those two, by combining those two, then we patch the WebUI to actually pull out from HDFS all these available metrics and visualize them. So you would get a view also of the new operating system level metrics that we developed, but also the existing ones that, like I showed before, the HDFS writes, the operations, and so on. So this is the slightly modified architecture that we designed for this to work. Again, you have your separate, on every node, you have your Spark workers, which launch the executors. And now in this case, our cigar source is attached to the executor. But this is not really required. The cigar source is only required if you want to have the operating system metrics as well. And now by using the HDFS link, the user would specify a directory on HDFS. In this case, it's custom metrics, let's say. And for every application that you run on Spark, we would create another subfolder with the application ID. And under that, there would be the HDFS sync will write for each executor those metrics that were the default ones, but also the ones that we created using Cigar. And by having all these metrics stored on HDFS, then the Spark WebUI could consume that and plot on the same WebUI that you would use to see all the other statistics for your jobs on the default Spark WebUI. Just some. I don't think it's visual, but so just some very basic instructions for how you can install it. The project is open source under the GitHub of IBM Research Ireland. It also hosts some other projects, some other open source projects that we did around Tachyon, Alluxio now, and some MPI projects. Basically, you need to build Spark as the official distribution as well. And the things that you need to do to get the monitoring part and the HDFS sync is just to specify on the metrics.properties the same way that you would, the same parameters that you would use for the CSV sync would be used for the HDFS sync now. You can specify the polling period, how often to obtain those metrics, and what directory on the HDFS should be used to store those metrics. And then, on the other hand, for the Spark WebUI to consume that, you just need to have the logging enabled, so you would get to that screen. You would be able to see that screen in general. And also, you need to specify the metrics directory from which the Spark WebUI should pull the metrics from. So if you want to see your metrics, you have to specify the same directory that you specified on the metrics.properties, and the same would be on the Spark defaults configuration file. Now it's a bit more cumbersome to install the operating system level metrics. Basically, you just need to download the Hyperic Cigar library to all of the slave nodes, extract it anywhere on the file system, and then you need to modify the metrics.properties file to attach the cigar source to the executor, and also let Spark know of the exact, on the library path, where are those library files stored on your disk, and then it should work without a problem. Okay, so now it's demo time. Okay, so what I have here, it's the just the cluster that we have in Ireland, and we can you can see on the historical applications that there is one job that I run, and we can visualize. So if you select that, This is the bit that we have added. It's the executor. This pull-down menu lets you select what type of metrics you want to plot. And as I said, so it's what you can see there, it's the default one that were already there on the file system level with the HDFS, the read, writes, the operations, and so on. But also, as you can see, we have added the cigar ones. Basically, currently what we have there is the CPU and the network bandwidth used, the disk read and writes, and how much RAM was utilized during that job. So let's try to plot the HDFS read bytes, for instance. And this nice plot shows up. And you can immediately see that there was, so every line is a different Spark executor. So you could clearly see that in this case, it was the executor 0 doing most of the heavy lifting. It was reading most of the bytes, as you can see, up to 3 gigabytes in the end, while the other ones were a bit unutilized. We can see now the operating system metrics, like the CPU. So you can see again that one executor, again, was doing most of the heavy lifting. Up to, in the beginning, it was up to 80% the CPU utilization. And just to show a bit of what's happening under the hood, basically, if you navigate to the HDFS on the directory, on the custom metrics directory that I have specified, there is one entry for every application. And if we have a look inside, you will see that there is one JSON file per executor stored there. So this is how a JSON would look like. I don't think it's very clear, but as you can imagine, it was just the metrics being written there. Okay, so as a roadmap, we want to make it more pluggable, the storage mechanism. We want to allow different type of backends to store the metrics. We want to support HBase or MongoDB, which would be fairly straightforward given that the metrics are in JSON format. We write them in JSON format in either case. Then when you store everything into HDFS, the metrics, and then you pull it out for the WebUI, there are some scalability issues there. Maybe if you have a very long-running job and you log the metrics for every second, then you would have some problems on the WebUI. Another improvement that we want to make is we want to provide to the user some smart recommendation on what is the infrastructure needs, and we have to focus on the patterns derived from this resource utilization of the previous jobs and come up with recommendations on that. Of course, we want to continue working with the open source ecosystem to improve and target more use cases and not just the internal, but see what other people, how can other people use it. For instance, there was someone on the GitHub just yesterday pinging me about having a headless version of this library, in the sense that he wasn't interested on the visualization part. He just wanted a centralized storing of those metrics to be, so he can retrieve them direct from HDFS. So we're working on that as well, having just the sync and the cigar source to write on HDFS without any visualization on the WebUI. So yeah, that's it. Thank you. And any questions?
All right, excellent. Let's get some questions. We've got 2 mics set up, and just a reminder, please get close to the mic if you have a question.
Hello. Can you show on the same screen the metrics and the stages of a job?
So on the demo? So here?
Yeah. Is it possible to, to see the DAG of the execution DAG to correlate which stage may have some impact or may have something?
Yes. So if you notice, so this job has only two. There are 2 stages here, right? So if you notice this vertical line, it notifies that it was the other one that started, the second one. And if you have a mouse over here, you will see that the state changes, right? So up on the right, it gives the host, right? So yeah, just to be clear on the operating system level metrics, we don't display executors anymore because it's we are plotting based on we group them by the node, right? So you will just see the host there on the upper right, and of course you will get the job and stage ID while you mouse over on every point, on every data point.
Where are you showing the IDs? The data point?
Upper right. The IDs of the jobs.
Okay.
Yeah, upper right. So the mouse over, if you notice here, it's you see, and this does shows that there is a different stage.
Okay, thanks.
Thanks.
Yeah, thank you for the talk. It was really interesting.
Thanks.
I was wondering if you have 2 applications running at the same time in one node. Is there any way to isolate this is the CPU usage of this application and this is the CPU usage of the other one?
So basically what the framework does, right, is that it gives you a snapshot. So the operating system level metrics, right? So on the cigar related metrics, what it gives you, it's basically an overview of what was happening on your system while you were running that job. It doesn't imply that the job caused that CPU, that RAM utilization. So basically, if you were running, let's say, this application, and you were doing some other Python or some other operation on the operating system, then you would see a spike there without having anything to do with Spark. So, but for us, it was useful as well to have a better understanding what is happening. But I think it's hard to get what caused the CPU load based on the application. It's kind of tricky, I think. But it would be very interesting to have. We are exploring ways to support that as well.
Yeah. Another quick question. Is there an explanation for that worker node having a much bigger load than the other ones? Because that's funny effect.
It just has to do with the type of job that you run. Maybe there is, I haven't went through the source code of Spark K-means, so I just launched a Spark K-means. Maybe, I don't know, it's something to investigate, right, on the job. Maybe, so I've seen this behavior, not on the CPU, but of course on the RAM when you do a collect on one of the nodes, then you will see that spike as well. Yeah. But it's interesting to have, so we consider that it's interesting to have all this view per job, right, to see what's happening per job.
Yeah. Ευχαριστώ.
Thanks.
Final question. What extra metrics should we be collecting from HDFS?
So we don't collect any additional metrics than the ones supported already by Spark. So as you can see here on the executor.filesystem.hdfs, these are the default ones. These are already generated on the CSV files, which would be large read operations, read bytes, read operations, write bytes, and so on. So we visualize that. We just write them into its DFS instead of the file system, and we visualize them on the WebUI.
Okay, thanks.
All right, looks as if there are no more questions. Let's give one more round of applause.
Yeah.